Hello everyone, you join us here at Axminster headquarters. My name's Colwyn Way, I'm one of the workshop tutors. Joining me is Keith Thompson, one of the senior machine experts here. We're here to introduce a couple of new machines. New machines but very familiar machines, and I'm going to pass over to Keith to explain why they may look so familiar.
Okay, these are the Powermatic machines. Powermatic being part of the Jet, Powermatic and Wilton brand empire in the United States. They've been around in America since 1921, so they're very, very familiar as a top brand in America, known as the gold standard. And a couple of years ago, Powermatic asked if we would be consider bringing their brand into the UK and European market. Of course, we're delighted to have a go at that. So we've been working with Powermatic to bring this compact little range of machines, starting with the two lathes, which are very familiar, as Colwyn says, because they've been sold in the UK as Jet machines for many years now. So Colwyn, if you'd like to perhaps run through the salient features of the two lathes.
So we'll look at some of the features in a bit more detail. So if we start off with the control system, the old Jet machines used to have a single mushroom button control system, really, where you push to stop and pull to start. We now got the green on button and the red stop button, and then to accompany that you've got the variable speed system itself. Now if I start the machine up again, use the control system, you'll notice that there's a really clear speed reader here, and that's controlled by the speed controller. Also, you've got two belt settings in here. So if I stop the machines, just to show you that briefly, we're currently on the high speed. So that will take us up to just under 3,500 revs, starting at 0. If we uncover the belt, just to show you with the actual belt itself, it's a poly V belt. Again, Keith, could you explain a little bit more about the technology behind that belt and what makes it so good?
Yeah, you'll find these belts on most car engines these days. They drive your alternator and power steering systems and air conditioning. The main thing about these, they have multiple V grooves, so that they have a huge surface area to grip, so you won't find any slippage. The belt itself is extremely even, so there's no vibration created, and they last for a very, very long time. They're very common in industry, and it's good to see them on a simple wood-turning lathe like this.
So you know what it's like, you're taking a big cut with a big gouge on a very big bowl, then you're not going to get that slipping, which you can get sometimes. So we'll shut that up. So the other things to take note of, you've got a reverse button there if you're into reverse turning or reverse sanding, that sort of thing. Literally just switch the switch over, and the machine will run backwards, or run in the other way, okay? Also, if you're into your big turning, it's important that you're able to get to that stop switch quickly. So we've got a really, really nice big mushroom stop button on a really long lead. There's around about 3 meters of lead there, so whatever you're turning, even if you're turning from center height to floor, you can put that somewhere to get to nice and quickly. For the safety conscious out there, we've got a safety cage, so schools, colleges, that sort of thing. If you're not into using that, then that can easily and quickly be removed and popped back. And on the same bracket, if you remove that cage, you've got the same bracket on the tailstock over there. We can use a couple of little centering pins, these two, and these are for copying. So if you've got something to copy, if you're into production work, you put your master copy up there. It's always in view, always easy to copy. So it's nice little features, really. Keith, what's the weight of this machine? What makes it so bulky?
Well, as you can see, this is entirely made of cast iron, which is one of the most dense materials you can ever make a wood-turning lathe from. It has tremendous vibration-absorbing qualities, but you can also, by putting some additives in the casting itself, you can create a super smooth surface here to allow your tool rest holder and also your tailstock to slide with a minimum of effort, even though individually they're quite a lumpy, pieces of equipment. So cast iron is favoured. It's not the only material in the world, but it is probably the most popular material to make a wood-turning lathe from.
Keith, also there's something about that thread that makes it a little bit more special as well. Certainly I've had a play with it, and it's a very smooth and easy to move tailstock. But you were saying something about the make of the thread as well.
Yeah, they use what is called an Acme thread, which is familiar if you've got a normal woodworking vise where you have a square profile thread. That enables it to stay clean of any dust and build up of rubbish inside it and still work perfectly, but also has a very large surface area, so you've got a lot of thrust without risk of damaging the thread. So again, it's very, very smooth in operation. You can see I can just whiz the handle around and it stays going practically. So it's extremely reliable but smooth in operation.
So that's the 3520 machines. That's the machine where most people will probably go for. But if you were looking for something a little bit bigger, or in fact a lot bigger, and you wanted to do some bigger items, we're going to look now at the 4224B. So we're going up now to a much, much bigger machine. All the same features as this one with a few more thrown in. Keith, if you'd like to start off.
Okay, well you can notice here we have a vacuum chuck already pre-mounted. This is a die-cast aluminium chuck with a neoprene seal in the centre, and it's driven by a vacuum being created in the centre of the headstock spindle. And so you have an adapter provided. And Colin, if you just excuse me, mate, I'll just pop round the back here. This adapter simply slides into the headstock spindle, and then you have a quick release connector which just fits onto here. You have to connect the lathe to a small compressor, but you don't need very much, 1.5, 2 horsepower at the most. And that, when it's switched on with this switch on here, will create a vacuum in the chuck itself, and you have a gauge to ensure that it's actually working. One thing to remember is that wood is slightly porous, so you do need a continuous airflow all the time. You can't just switch the compressor off. Your work will come away from the chuck. And again, when you don't want to use it, you just unplug it and then you can store it away. You need to be able to get at the headstock spindle to remove your centres when you're turning between centre. And if I may, Colwyn, the other feature on here is you have your indexing system, which is very, very clever. You have a 12, 24 and 36 graduation hole set on this disc, and then you have a system here which will allow you to move the indexing pin, which is on a spring, to the ring that you want to use. So you can just hold it in place, do up the hand, clamp, and then it will fit into place like so. So you can just screw it up, and you have, say, 36, 24 and 12 graduations. So you can do all your fluting or piercing work and everything you want to use.
Okay, so like we said, it has all the features of its smaller 3.5, but with a few more thrown in. Now, for instance, we're going up to an extra belt setting just to take on board those extra big lumps of timber. Same poly V-belt system, so a huge amount of surface area in there, but you've got that extra pulley position. And one thing we didn't mention, on the smaller machine, it has the same spindle locking system, so it's on a spring pin here, and if I just pop that in and turn the spindle, there we are, we're locked in. If you want hands free and hold that spring pin in, then we just drop that down, and your hands free to take your chucks off, face plates, that sort of thing. And then just flick it back up and we're out again. So there, clamping system we haven't mentioned yet. We've got a double clamping system on this one. So again, yep. Keith.
Yeah, you need a spanner which is provided. And unlike the smaller model where it has a single clamping bar holding the headstock to the bed and a hand lever at the back, you need a spanner on this one. And you've got twin clamps, so that means that when you've got the headstock slid to the end of the bed and you're turning off the end of the bed, and you need this clamped really, really securely, because you could have a very, very large piece of timber attached to the chuck. So you just have two clamps on here, and if you undo them both, it's just quarter of a turn. You can then slide the headstock. Again, although this is like 100+ kilos in weight, it's not that hard to slide. So it, again, testifies to the fine grinding of the bed and the careful matching of the surfaces underneath. So you do need the spanner, and it has a little home for itself in the tool tote on the back of the stand.
Okay, so one of the most important things that we haven't spoken about is the motor themselves and how they deliver such power to the spindles. So Keith, if you can explain a little bit more about the two motors.
Yeah, with your smaller machine, it's powered by a 2 horsepower motor, and this one is a 50% increase to a 3 horsepower. Both instances, they are driven by an inverter, which lives under a cover at the back of the machine. It's actually surface cooled, so there's no fan to draw dust into it like you get on so many other machines. So the inverter actually controls how the motor functions. So even on a very, very slow speed, and it's on the slowest belt speed now, it's a bit like your car engine. You get the maximum torque or pulling power to propel the headstock spindle around. But also, the inverter itself is cleverly sensing the speed of the motor and the load applied, and actually puts a little boost of power in when you apply a load, so you get that spindle running at the same speed. There's no jerkiness. You know, it's smooth and easy to use.
So there we are, a couple of great lathes from Powermatic. These are the two of a family of machines that we're going to be introducing over the course of the next few weeks. And certainly a couple of the most robust lathes I've ever worked on. Certainly lathes to aspire to.